Okay, so continuing with our tutorials on Arduino, I'm going to present or explain to you a little bit about the software and how the software is configured, how you can write some pieces of code, compile them, and down the code down to the microchip. So let's see how it works. This is a simple blink code that is going to turn on and off an LED in the Arduino board. So let me explain you the most important parts of the code. In this section on the top, we have the comment section. So we start with a slash and an asterisk sign, and then we put the comment. So this section is important because you can put your notes and dates or whatever you want to put here in order to remember what the software does. So it's really important to document your job and your progress. So this is the section to do it. When you use two backslash in two slashes, I'm sorry, one after the other, this line becomes also a comment line. So this section of the code is not really code, it's just comments for your own use, so you can remember what the code does or put notes or whatever. So in essence, this code is the same as this one and is basically comments. This section over here is the variable declaration, is where a variable is a space of memory in the microcontroller, or in Arduino in this case, where you have variables that usually don't change across the software of the program, or sometimes change. It depends on the flow of the software that you write, but this reserves some space of memory in the microcontroller to hold these variables. The next section is the first function that is really important in the Arduino program or sketch, which is called the setup. The voice setup is a function that performs the setup of the microcontroller. It happens that the microcontroller, you can control which digital lines are input or which digital lines are outputs. You can also control the speed of the communication in the serial port. So all that combination of variables or the environment that you want is set up here. So in this case, for instance, we have a pin mode function which takes the argument LED, and then the option is output. Translating this a little bit means that the pin mode is going to be configured in LED, but LED has a value of 13, as you can see here in the top. So the pin 13 of the Arduino is going to be configured in this mode. Which one? Output. So it means that we're going to be generating values from the Arduino to the external world through the pin number 13. So that's in a sense what we're doing here in this line. The second function that is really important in the Arduino sketch is the loop. The loop is an infinitive a sequence of functions or instructions that we give or we provide to the microcontroller, and the microcontroller is going to be executing line by line these functions over and over and over. So it goes from the top, then goes here, until it reaches the end of the loop, and then jumps back to the beginning of the loop section and keeps going and going and going. So it does this forever as long as the Arduino or the microcontroller has power. It's going to be doing that forever. So that's called the infinite loop, or just loop, and is where we put the main section of the code. The main instructions are given here. In this case, we are using the function digital write. So digital write sets the value of a digital pin or one of the outputs in the Arduino. In this case, we're using the pin LED, But remember, LED has a value of 13, so we are writing to the pin 13 a status of high. So high means that it's a high voltage in the Arduino world. And a status of high means that it's a 5 voltage level for the microcontroller. So we are sending 5 volts or status high to the pin 13 in the microcontroller. Then we use a function called delay, which is simply like a time delay function for the microcontroller. Is a function that does nothing, just waits for X amount of time. In this case, we're using 1000 as an argument for this function. This value here is in milliseconds. So if we express 1000, it means 1000 milliseconds, and if you do the math, 1000 milliseconds, it's exactly 1 second. So we can control here the time in seconds, just put in thousands if we want to have delays in the second range, or if you want delays, smaller delays than that, you can just put 100, 200, 10, 50, whatever. But remember, it's milliseconds. So depending on the value that you have here as an argument, you get X amount of delay. And the next line in this example is another digital write. So it's going to write to the LED pin. Remember again, LED pin is 13. But in this case, we're going to be writing a low value. So it means that we're going to send in a 0 volts value to the digital pin number 13. And that's going to turn off the LED. And then we're gonna do the same as before. We do a delay of 1000, meaning 1 second, and we keep looping and looping these instructions over and over and over. So we turn on the LED, we do a delay of 1 second, then we turn it off, delay 1 second, then we jump to the beginning, and the code keeps doing this over and over and over. So that's really simple. As you can see, the final effect that we see in the hardware is an LED blinking with a frequency of 1 hertz or 1 second that you can easily adjust by changing the values here in the delay. So that was the first basic example, and then is the first one that everybody does to check the board or to start learning a little bit of Arduino. Thank you. Okay, so keeping up with our first or second, is going to be the second lab. I'm going to wire up a couple of LEDs. I'm going to put a total of 4 LEDs in the board. So remember, using the same approach as before, taking care of which one is anode and cathode. I'm going to place 3 more LEDs on my breadboard, just like that. The third one. Let's do the last one. Okay, and now some resistors, same thing as before, from the cathode all the way to ground in the board. So that's one. This is for the other one, and 2, and then the last one, 3. There you go. So we have 4 resistors, 4 LEDs, and we are gonna wire this up to the outputs in the Arduino. So this is gonna be going to the pin number 12. Next one is gonna be 11. Okay. And last one is going to be 10. Okay, so we have 4 wires coming from the Arduino board all the way down to the LEDs, and the LEDs in series with some resistors down to ground, and is ready to go. Let's put some code and let's try this. Okay, so I'm going to plug the USB connector to my Arduino board. You hear the sound of the computer, and as soon as the board gets the power, it's gonna start running the previous sketch, which is the blinking LED, just blinking one LED in the pin 13 with this wire. So now I'm going to upgrade my sketch or my program here in the microcontroller. So I'm going to download the code to activate the other 3 LEDs, and you can see the difference. So I'm going to open my sketch here, and I'm going to upload this code right now. The transmission's LED blinks for a couple of seconds, and then everything gets updated. And as you can see, the 4 LEDs are blinking, but they are taking turns, is in a sequence. From the first one, which is 13, number 12 is this one, 11 is this one, and 10 is this one. So this thing is blinking 1 second, and then goes off for 1 second, and keeps doing that forever. So I'm going to modify real quick the code here. I'm just gonna get rid of the off conditions of the LEDs. So what we're gonna be seeing is just one sequence. Let me do this. I'm modifying the code right now, and I'm going to compile this and update the code right there. So you can see I'm not turning off the LEDs, I'm just leaving the last LED on, and it does that one time and then it stays there. So at this point I can easily modify the code in various ways. For instance, I'm gonna change the time in the delay. I'm gonna be doing this thing but a little bit faster, so I'm gonna be using a delay of 200 milliseconds. Let me modify the code. 200. Okay, I'm done with the code. It's uploading, and as you can see, I'm keeping the same sequence as the beginning, but the LEDs are blinking much faster because the delay in this occasion is only 200 milliseconds. Great, so we have the lab number 2 for the Arduino projects. I hope you have enjoyed this one, and you can play a little bit with the code and find different combinations, different sequences, and that helps you to get familiarized with the Arduino environment. Thank you very much for watching this video.